Yeah, guys, so there's your Cryosuit running, and as you can see all of our little guys. Oh, that feels so good. This is the cold one. I'm running it in different orients to see what the efficiency is, but if we zoom out here a little bit, let me move this out of the way. You can see even as it's running right now, like these right here, if we do the electrical box right, we might be able to have it down to just like 2 front pockets or a tool belt. Should be really cool. We wouldn't even have to worry about the shirt part up here, and we'd be able to sit in cars and do a lot of other cool stuff. We'd be able to wear seat belts, obviously, because we'd have it below the waist or on the sides. So a lot of cool opportunities would open up. I gotta get headers on this thing though, obviously, and I gotta get it sealed for thermal protection and for fire protection. But we got something really cool for that. It is I found Great Stuff makes a fire block foam, and it is UL classified, and it's even code identifiable orange. It's made in the US. It's even like a component of Buy American. But this does all kinds of good things, and it's insulating, and it fills all kinds of cracks and holes and stuff. And I'm gonna figure out through a CAD model how to design a semi-hermetic box for all this stuff to go in, because one of the things that might happen down the road if you own this is it might break. And knowing a lot of technicians, well, they provided some instruction manuals, they'd probably like to fix this thing. So one of my little goals here is I'm going to design the top piece of this box so that it comes off and doesn't completely cover these things, so that these guys might be able to slide or pick out the box around it, because the box is just plastic. And then be able to dig these out with a screwdriver, or be able to even pull them out individually, since all these are being held in here with is a form of compression to hold these stacks or these blades together. These are little mini blades. If you see the big ones over there, those are big blades for big applications. But you've got a little blade core. You actually have 2, and you might notice that, Nick, one of these is bigger than the other. And yeah, actually that's intentional for a number of reasons, and we can get a number of cool applications out of that as a result. And a lot of you in the HVAC industry know that sometimes with an air conditioner we have 2 compressors, and people want to stage their capacity, so to speak, for efficiency purposes. So they'll have a big compressor and a little compressor, which is really cool in air conditioning. It allows you to accomplish a lot of neat stuff at a low price point, because you can run your system more efficiently. You don't necessarily need a fancy dancy inverter, but if you wanted to, you can even add an inverter to that application. So that's very cool, and that's something that you can do to reduce cost in your design. I can get you an excellent product that has staged levels of capacity. Even on the cheapest model, it stages its capacity, which means it's more efficient, and it draws less from these guys, which I still have to go in, and maybe I'll do something on protecting lithium battery cells. Like, if you're going to make your own battery pack, what do you need to do to make it safe? Well, obviously, man, we're going to want some more of that stuff, aren't we? Yeah. And that's probably what we'll end up doing with these bad boys, but there's some electrical wizardry that we have to do to make sure that these things are safe too. As anybody who's ever built a battery before will tell you, is you don't just throw these things in a box and go. what are these things? I mean, if they're so light, these are lithium rechargeable batteries. Particularly, these are an amorphous gel, which means that you don't want to be trying to stab this thing. You don't want to be, crushing this thing. That's not a good idea, and it never was in these batteries. And some heavier lithium cells will have steel protection on them, which means that, again, Nick, I care about my safety. Obviously, what I'm going to do is find you a very strong impact-resistant plastic to put these in. And I have some really good ideas and some things that are called metamaterials, which have integrated components of either metal or carbon fiber. Carbon fiber would be really cool for this application, and I'm probably going to do that as a prototype. But yeah, if we see here, have things gotten, they went a little bit higher because now we're reaching the point where we're actually pumping heat out of the top of the system, and this isn't just kind of free flow charging up all the tubes. Which again, this, as you can see from my thermal pictures that I put out, this is an extremely lossy system, having all these big open pipes like this. You definitely want something secured. Another electrical engineer will tell you, oh man, that's a joke having the long cables like that. Well, I know that. I'm actually going to get more efficient than this, because these cables, these are BNC cables, and while they have about, I would say 18 to 20 gauge, somewhere in that realm, combined with their shields, and it's a good conductor cable. I mean, they're long, and they're going to make heat when they're super duper long like this. So that's another component of loss. So it's really cool to see that we were getting those temperatures at, just about 10 amps, 10.2 amps at the most, and 4.8 volts, which is very cool. It's a light bulb, and that's about the limit of what this bad boy can put out too. That's another thing that I wanted to talk about. I'm stressing the crap out of my little, this is an Arduino and other science project power supply, and that's what this thing is. It's not some sort of fancy beep boop bleep bloop computer thing. It's a power supply, and this up here tells you your volts, and this down here tells you your amps, and it's for science projects, of course. And what you can do is, well, this guy's mad, and I locked him into parallel mode so I can get the absolute max power out of this little guy. But I can go in here, and it allows me to adjust the voltage, but more importantly for these, it allows me to adjust the current. If it will even listen to me, and it may not, because again, I have everything maxed out on this, and that's about as much as I can give. It has this locked. So anyways, you can see it's delivering about 50 watts. I need to shut this thing down because it's stressing this thing out as hard as it can go. I have a bigger power supply that's coming in for more comprehensive testing at higher wattages. And it's just not a good idea to run this thing on just some unprogrammed chip or some cheap power supply. So I'm going to have to build a bigger power supply while my bigger power supply comes in, obviously, which could be anywhere from a week to 2 weeks from now. So that's another reason why I just want to keep teaching for the time being. I got another machine that I got to work on. And I obviously got some components of this to build before I can pump any real significant amounts of power into this suit. But what is the suit? This is the second generation Trapani Systems Cryosuit. And this is what I intend to help all of my workers in the factories that I've seen suffer, and all of my technicians out in the field that I've seen suffer from the heat, and all of my friends and family and all of you people out there that I've seen suffer in the heat. And the best part about this suit is that it is reversible. So potentially, with the right mechanisms, the whole system can be reversed and it can be taken out in the winter. And yeah, provided we put the right stuff in the water, yeah, you can go freaking mountain climbing in the winter with a thin little jacket on that's reflective on the inside. I'm right there with you guys. This is an exciting time to be alive. We've got incredible battery technology that's just now getting cheap. We have incredible solid state cooling technology that I've now figured out how to get efficient and possibly scalable. The scalable part is dependent on literally me right now, which is kind of scary. So I have to come up with some other inventions that will help make this scalable. Obviously, now kind of proven that the solid state part might be scalable, I have to make the system as a whole scalable. And that's the name of me, and that's what I do. And that's my absolute goal here as Trapani Systems. Is one of my products is to deliver you what I call the Cryosuit. So that's my product. That's my idea. I have metadata on this now that I've recorded this, which is really cool. But that's what I intend on bringing to all of you guys. My name is Nick Trapani, and I am Trapani Systems. Thank you.